All right, ladies and gentlemen, we got chapter 11, 6, day 2. So again, we're just graphing these quadratics. All right, and that's our goal for is accurately graph a quadratic function in standard form. And reminder, standard form looks like this, where it's y equals ax squared plus bx plus c. And we'll talk about domain and range a little bit using that interval notation. Okay. So let's get started. So again, we're using that standard form. And then we talked about using the axis of symmetry, which is here. It says it's x equals negative b over 2a. I like to write it like this. Negative b over 2a, like a normal fraction. So that's the first thing we're going to do. And today is our first time where we have a b value. You know, this is very similar to what we did on Friday, but Friday all the b values were 0, so we didn't have to really worry about that. So as I take a look, for example number 1, I've got y equals x squared minus 6x plus 1, a, b, and c. What's the a value? What's the number in front of x squared? What do you got here? Kai, what's the number in front of x squared?
1.
There you go. Jasmine, what's the b value? What's the number in front of x? Close. Yep, negative 6. And then the c value, the one that's all by itself, is just 1. Don't really need that for the formula, but you'll see that that is your y-intercept. So as we take a look, I'm going to go ahead and plug those numbers in to negative b over 2a. So I have the opposite of negative 6, and then I have 2 times 1. When I take the opposite of negative 6, we should know that's positive, right? So that becomes 6, and then 2 times 1 is 2. So we finish up, and 6 divided by 2 is just 3. Yep.
Is the C value y?
The c value you'll see is the y-intercept.
So is it going to be 1?
Eventually, I'll show you what the c value is in a sec. Okay. So this is again our axis of symmetry, or AOS. That's our 3, and then that is our point for our vertex. Okay, so I'm going to go ahead and graph my axis of symmetry. We'll do this in pink here so we can see it. Remember, axis of symmetry is what cuts your graph in half. And then somewhere on this axis of symmetry, x equals 3, somewhere is this vertex. Right? So, if you need to, make a little table. And we want to plug in 3. Yep. So go ahead and plug in 3. And when you're plugging in, please excuse my dear Aunt Susie, or Sally, or Sharon, or whatever your aunt's name is that has an S. So I'm going to go ahead and plug in 3 anywhere that I see an x. So I've got 3 squared minus 6 times 3, and then plus 1. All right, so that's what? 3 squared is 9. Negative 6 times 3 is negative 18 plus 1. And that ends up to be what? What's 9 minus 18? And then plus 1. 9 minus 18? Negative 9 plus 1 is negative 8. Perfect. So our vertex is negative 8 plus u. Okay. Now, unfortunately, that's going to take us off the chart for this graph. I'm just going to extend this if you guys are okay with that. Here's negative 7, negative 8. So I'm right here at negative 3, 0. Excuse me, positive 3, negative 8. So I just extended that just because our graph is just off a little bit. You guys okay with that?
It won't do that on
you should fit it, be able to fit it, yeah. With my math lab, yeah. All right, so let's go ahead and graph this thing. What do you say? What do you say? All right, so normally my parent function, it's over 1 up. How many? Over 1 up 1. Over 1 up 1. Over 2, 1, 2 up how many? What's 2 squared? 4. 1, 2, 3, and 4. Over 1, 2 up 1, 2, 3, 4. And now if I want even more, I could go over 3 and then up 9, because 3 squared is 9. I could, you don't have to, but I could go over 3 up 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I want to graph this one so you could see that's the y-intercept. Okay. Over 3 up 9 would be right there. So you would have a nice looking U shape.
That's a lot.
I graphed a lot of points there, but again, when you're graphing with my math lab, you need the vertex, which is in our case 3, -8, and then you need to graph one more point. Okay. How are we doing with that? You guys good with that? Domain and range. Domain is always the same thing. This thing goes all the way to the left and all the way to the right. So -infinity to infinity. And your range is again bottoms up. At what y value do you start seeing it? What's this y value? -8. So it goes -8 all the way up to positive infinity. -8 is part of the graph, so I'm going to use a bracket there. Okay, so as I take a look, this value here is in relationship to that value. You guys good with that? That's not so bad.
No.
All right, we got example 2 and 3. Let's do example number 2 here. And I've got, any questions on 1 before we move on? Now I'm going to show you how to use your some of you guys have your graphing calculators. I'm going to show you how to use your graphing calculator to plug in some numbers. Okay. So if you do have a graphing calculator, why don't you get it out so I can show you. As I take a look, I've got example 2. I've got y equals x squared minus 4x plus 3. So off to the side, I like writing my A, B's, and C's. Okay. Don't really need the C value, but that is the y-intercept if you ever need that. Okay. So my A value is the number in front of x squared. What's the number in front of x squared if you don't see anything? Just 1. And then the B value is the number in front of x, which is what, -4. And then C is 3. All right, now it's time to plug it in, We want our AOS. So I'm going to use that x equals -b over 2a formula. So I have the opposite of -4. And then 2a, so that's 2 times 1. And we're okay with the opposite of -4 is +4. And then 2 times 1 is 2. And 4 divided by 2 we know is 2. So my AOS, my axis symmetry, AOS for short, is x equals 2. So I'm going to go ahead and graph that little. And when you're graphing, that's one of the things they ask you to graph, is that axis of symmetry, and they want it dashed. So draw that line up and down through 2. So I've got x equals 2 there. Now somewhere on this axis of symmetry lies my little vertex, right? So again, somewhere It's 2 comma something. Now you can plug that in, or you can use your calculator and plug it in. So some people like using their calcs. I'm going to show you how to do that. Okay, so again, quiz or test, this is a great thing you can do. Make sure you get this thing right. I've got x squared minus 4x. So I'm going to go to y equals. Y equals is up here. Okay, and I'm going to type it in. I've got x squared. So x is right here next to the alpha. I've got squared is kind of kitty corner to the 7. Here's 7. So squared is up there. Press that. So I've got my x squared minus, big minus sign, the one on the far right above the addition sign. 4, and then x, this guy right here. And then I have plus 3. So again, I've got x squared minus 4x plus 3. If you have a graphing calculator, you can use it. Zoom. Zoom is right in the middle, so I always do zoom 6, zoom standard right there. Zoom 6, you can toggle down to zoom 6, or just press the number 6. And it should give you that nice window where this is negative 10 and this is 10, and the y's are negative 10 to 10. Okay. So again, the idea is I have right here at x equals 2, a nice little vertical asymptote. Let me use a blue color so you can see it a little darker. So it looks like this. All right, so there's a little vertical asymptote there. Let me change the coloring here. Let me get darker. There, you see that now? Okay, don't freak out. This erases, yeah. So I've got my little axis symmetry that I drew in, and then I want to find out, well, what's that coordinate point? Well, what we can do is we can go second trace. So second trace is my calculate menu, and this allows me to plug in values. So if I press value number 1, I can plug in any x value I want. So if I want to plug in 2, just type in 2, enter, and it allows me to type it in. If anybody's working with their graphing calculator and they're not getting this graph, let me know. Okay, so I plugged in 2 and I got negative 1. Okay. You could also do this by hand. Plug in 2. 2 squared is 4. Negative 4 times 2 is negative 8, so 4 minus 8 is negative 4, and then plus 3 is negative 1. So you can do it different ways. You can do it by hand, do it using your calculator. Okay, so I'm going to go ahead and graph 2, negative 1 as my vertex. Any questions on how I got 2, negative 1? Just a little pluggy chuggy. You guys can do that. Please excuse my dear Aunt Sally for doing it by hand.
My calculator makes it way harder.
No. No. And now this is where I need to graph some more points, right? Because my A value is 1, I know it's a smiley face, and I see it on my graphing calculator here. I'm just going to follow the basic pattern. Okay? So right here, over 1, up how many? Over 1, up 1. Over 1, up 1. Over 2, up how many? 4, because 2 squared is 4. So over 2 x's, up 4. 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. Don't forget it's symmetric. Dun, 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 dun. It's symmetric. And we got a nice looking graph there. Okay. Things that you should be able to answer should be. Okay, they might say, hey, Jimmy, Johnny, Cindy, Megan, what's the x-intercept? So you should be able to look at this graph now and identify where it crosses or touches the x-axis. You guys see where it touches or crosses the x-axis? What do you guys got for the x-intercept? If they ask you that question. What's this guy right here? And right here. What's this one? Mariana, what'd you say?
1.
1, so 1, 0. Perfect. And then this one right here is what? 3, 0. Okay, so those are my x-intercepts. And then it also has a y-intercept. So if they ask you for the y-intercept, we should be able to give that. Where it crosses or touches the y-axis. Here's the y-axis. It'd be this guy right here. So this one is up 1, 2, 3. That's 0, 3. And then, Claudia, you're asking again about that C value. That is your y-intercept. That will always be the y-intercept. So it was y equals x squared minus 4x plus 3. That 3 is always where it crosses the y-axis. Same thing here. This one, example 1, was that 1, and that's where it crossed the y-axis. Okay. Okay. Domain range. Domain is just what? Always, always, always. Negative infinity, infinity. Range is the tricky one. Don't see it, don't see it, don't see it. Ooh, I see it right here. Right? What's this y value right there? -1. Very good. So it goes -1 all the way up. Never stops to infinity. So if they do ask domain and range, domain is all reals. Range, use the y value from your vertex. Okay? All right. Do we have any questions with 1 or 2?